Welcome to today's episode. On this episode, we're going to talk about the open-closed principle of the solid principles of software design for clean code. The open-closed principle is that software entities, these are classes, modules, functions, etc., should be open for extension but closed for modification. And it sounds a little abstract, so we're going to show how you can accomplish this by using dependency injection and first using structs protocols and more of the model view architecture. And then secondly, using a class, which is an observable object. And there are two ways of doing that, using either inheritance or protocols, and then following the MVVM architecture. And I'll try to cover all this in a clear way as possible. And we're going to use SwiftUI. I've already created an initial starting point here, something called a clock view. It's got three properties: hours, minutes, and seconds. They're all set to 0 for now. And then the var body is an H stack with text as hours, minutes, seconds. And then I just made it a large title so that we can actually see this thing. And very convenient is the monospaced digit that gets rid of the wiggliness. So for instance, if minutes were 1, like this, and you would see that with monospace, it doesn't change the size that it takes up. But if you comment that out right here, and you'll see that it is significantly narrower now than before compared to monospaced. So I think the monospace is very helpful. Okay, now we have this. Obviously, this is just to get started. If we wanted to use state vars, hours, minutes, and seconds, you could still do that. But instead, we're going to jump straight into the structs. I'm going to create a struct. We're going to call it a clock model, and it's going to have these things in it. So they're, instead of lets, they have to be vars. And then there has to be a function called update. And that's going to be used to update these values here. Okay, so what we'll do is copy over some code that I have prepared to update the time. So here we go. So we'll let a date, excuse me, this has to be a mutating func, update. Now, you create a date, which is basically the current date, calendar, and then calendar.component, and then hour from date gives you the hour, minutes, and seconds as date components. And then we can merely convert these integers into a string format using string format %02 that makes sure that this pads left 0, 2 digits, hours, minutes, and seconds. And what results is this particular view right here. So let's use that clock model now. The way we're going to do that is make a state variable. It'll be at state var, and then it will call it just VM, which is equal to clock model, like this. And then we're going to get error messages right here. So we're going to convert that to vm.hours, vm.minutes, and vm.seconds. I think what you should see is you still have this working properly. Let me just change some values here to make sure that it is connected. And indeed it is. We can see that now we have replicated the previous functionality of the view by adding a state variable. And now, obviously, we want to be able to show the clock and have it go. So what we'll have to do is create a let timer equals timer dot publish, and then we're going to publish every let's say 0.2 seconds, run loop on the main. Sorry, and let's see, run loop that mode is .common and auto connect. And what you'll see is that we can, it's still not gonna change the time here, but what we can do is we can change the time by doing this. Dot on receive, the publisher is the timer, and then perform. We don't need the variable there. We just need to do a VM.update. And that should actually give us the current time. And there it is, and it's updating, changing every second, although it's the timer is being published every 0.2 seconds. So maybe that's not necessary. We could just publish it every 1 second like this, and that should still work. And there you go. There you go, it's still working fine. So this is how you would do what's called a model view architecture. The model here is the clock model, and then we have the view. All right, so then the next thing we can do is we can do some dependency injection. So what we could say is that we'll just declare this a clock model, and then over here we would have to inject in the model, right? So now here we go. Still works, but we're injecting in the model. We're not instantiating the model inside of the clock. Another way you could do this is to declare a state variable here and send a binding in, but this is the way we're just going to do it for now. All right, now you're going to say, well, I see that it works with a struct, but what about the protocol? So let's go ahead and make a protocol now. So I'm looking at this clock model and I see the key parts of the protocol that needs to be made. So the protocol that needs to be made is going to be called the clock protocol, let's say, model protocol. And it's going to have these things in it right here. And var, but of course you cannot set values in there. But, and let's see now. Set and get, and you got that. That should, oh yes, it needs to be strings, obviously. All right, so these are going to be declared as string variables. Here are set and gets, and there's a protocol. All right, so now instead of declaring in the view here a clock model, we can declare it as a clock model protocol, right? But that's going to give me an error message right over here. It does not conform to clock model protocol. Okay, so how do we fix that? Well, we're going to go here, clock model protocol. And now that's going to conform to the clock model protocol. And let's build it. And it succeeded. And voila, it's running. Now what that means is that we can make another clock model. We'll call it something else, you know, countdown clock, and that it, so let's see, we can just do this, copy. And we'll call it clock model number 2. That's not a good one. We'll call it 2 like that. All right. So then we could say change the update over here to something else, such that you can make it go up or down or whatever functionality you want to change here in the update. Okay. So then what that means is over here, we can inject in clock model 2 like this, and it should still work. Let's see. Ooh, cannot find clock model 2 in scope. I thought I did that. Oh, 2 PW 2. All right, so in this manner, then we were able to use a protocol like this, and then you inject in the dependency over here to make this happen. So for instance, in model 2, that could have been a mock instead of model 2, and it really had a completely different update function here. It could have just been saying, you know, hey, let's see, let's just get rid of all that and say hours equals 12, and then minutes, so it would be, yeah, minutes equals 20, 22, and seconds equals, I don't know, another number, 00. So then what would happen is, let's see, model 2 gets in there. I'm gonna, there it goes, 12, 22, and 0, 12, 22, and 0. So this is a way you could mock, you know, for testing purposes. So dependency injection can be very useful for those kinds of things. Now, what we've done here is we've created an ability now to modify the behavior without changing the code. And that's really the open closed principle in action right here, right? And so we did that by dependency injection and protocols to make this happen. All right, cool. Now, I said what we would do is another way of doing this. We could do it using class, and that is an observable object using inheritance and protocols, and that would follow the MVVM architecture. So let's do this now. Let's just go like this. Yeah. And we'll go here now. So let me just put this all down below. It doesn't get in the way. We'll have a class. Okay, so what I did was created a little class called ClockVM for a view model. It's going to be an observable object, and it's going to have the following. It's going to have a variable that's published for our hours, published for our minutes, published for our seconds. And then we're going to do some combine magic to simplify the view code even more. So we're going to import combine, and that gets rid of this particular error. Next, we need an update variable. So for that, we'll just use our trusty update right here. Boom. All right, very good. So now we can inject that into our code by creating a state object for our VM equals clock view model. And then let's see now. This needs to be a clock VM. And we're gonna say, hey, we're gonna put this in VM. And now we can comment that out. Oh, and we can comment this out. And it should still work. So let's see now. What's happening here is we created a timer inside of here, and it needs to update. So then we'll have to call this an observed object and clock VM. And what you'll see is that now when you make this an observed object, the time actually updates. Wowee. And the cool thing is now we can get rid of this code can go away. And then this code can go away. And wow, that view looks really clean now, doesn't it? It looks so clean. Yeah, okay. So that works good. Now we're injecting in the view model into here to make this work. So now you could potentially change the behavior of the clock VM. So for instance, you could say class clock VM, and then instead of making an observable object, we're going to say clock 2 VM. And it's going to be inherit from clock VM itself. And boom, we can inject that in right here. So clock 2 will be like this. It works beautifully. Inheritance. Now we can then override update. Say func update. So we're going to say override func update. And now if you have nothing in there, then it won't update at all. But we could try other things to do a little update differently in here. And so now what we're able to do is, without changing this code at all, we left this as a clock VM. We didn't have to call it a clock 2 VM because of the inheritance principles. Okay, so that's one way of doing it. So using inheritance is really convenient, obviously, because you don't have to rewrite all this code. It's super clean. We love it. But you could potentially use protocols instead of using inheritance, even with a class. So to make that work, we have to get rid of mutating func. And what we could even do is we could give it an extension and extension to the clock model protocol. And we could say func update. And we can just put that right in there, boom, like so. Copy, paste. And instead of this being, okay, so here we go. We can actually make this an observable object right there, the protocol itself. Let's do it over here. Now the clock model protocol will be an observable object. There'll be a default func update. That means that we don't need this in here anymore. Get rid of that. Boom. And then we got to make this conform to clock model protocol like that. And that looks pretty good now. And then we could, like so. Okay, there we go. So now instead of going like this, we can actually say that it's going to conform to a clock model protocol. Oops. So type T, and we can say type T, boom, like so. And with this kind of setup, then you don't necessarily need inheritance at all. You just passing in a clock model protocol object, and then you're going to have to inject it in right here. And instead of 2, let's call this just 1. And resume. And there it goes. That's working beautifully. And then if we want to do update and have our own little thing here, we could actually say in the clock 2 VM that let's say hours equal, instead of 00, we'll say, 24. And when it resumes, okay, so without changing this, we're going to change the behavior by just changing this right here. Boom. And bam. There it is. Clock 2 VM. 2 VM. VM. Okay, so I actually had to make clock 2 VM conform to the protocol instead of just inheriting from clock VM. And then what that means is you have to rewrite, these published variables, because it's no longer just inheriting it from the clock VM. This is a class of itself that just happens to conform to clock model protocol, which means you have to have variables, and then you have to implement these functions and variable as well, and then you can update this. So a lot more code to use the clock model protocol, but there's sometimes when this can be advantageous as opposed to using inheritance, which sometimes can be difficult. Okay, that's all.